Welcome to Homework Lib.
The distribution of X, the amount of coffee that people drink per day, is normally distributed, denoted as X is distributed to a normal distribution with a mean of 14, so 14, and a standard deviation of 5.5, so 14 and 5.5. The distribution of X bar is also normally distributed. When the sample size is large enough, greater than or equal to 30, and the population is normally distributed, the distribution of the sample mean becomes approximately normal, regardless of the shape of the original population. And so the mean stays at 14, but the standard deviation is now what was the 5.5, but divided by the square root of the sample size, which is 32. And to 4 places, 5.5 over the square root of 32 is 0.9723. To find the probability that one randomly selected person drinks between 13.9 and 14.5 ounces of coffee per day, we need to find the cumulative probability using the normal distribution with the given mean and standard deviation. So we need to calculate two z-scores. The first one for 13.9 and the second for 14.5. And for 13.9 is negative 0.0182, and for 14.5 is 0.0909. And so the probability that a person drinks between 13.9 and 14.5 ounces is the same thing as the probability that the z-score is between negative 0.0182 and 0.0909. So you can go to the standard normal table or a calculator. And that calculates to 0.0435. When this is for now, the 32 people find the probability that the average coffee consumption is between 13.9 and 14.5. So you'll just get new z-scores. We'll use the 0.9723. So that's 0.5142 and negative 0.1028. And this comes out to 0.2374. For part D is the assumption that the distribution is normal necessary. When the sample size is sufficiently large at greater than or equal to 30, the central limit theorem ensures that the sampling distribution of the sample mean is approximately normal, even if the underlying population distribution is not normal. So it's not necessary to assume this with 32. Find the inner quartile range for the average of 32 coffee drinkers. Well, the first quartile is the mean minus the first quartile z times the standard deviation of the sample mean. And so Q1 would be 14 minus the first quartile z is negative 0.675. Negative 0.675 times the standard deviation over the square root of the sample size. And we're going to 4 places. That's 14.6563. I think I just got those backwards actually. This is going to be Q3. And Q1 is going to be 14 minus the negative, which to 4 places is 13.3437. So the inner quartile range is the difference between them. And that comes out to 1.3126 to 4 places.